All right, we're back. This is the MIS course. We're doing chapter number 6. We're talking about part number 4. We left off with talking about different networking topologies. We left off with the ring topology. Now, the ring topology, I think you can pretty much understand why it's called a ring topology. It's just computers connected in a ring. You don't see these very often. It was developed by IBM. It's usually for smaller networks. It's not as efficient because you've got data that wants to travel, let's say, from this computer to this one. It has to go through the computer here, another computer, and then finally gets delivered. So a ring, they call it a token ring topology, where a token keeps circulating around at the speed of electricity, picking up data packages and delivering to the computer that it needs. Basically is how it works. And it falls in one direction. All right, the next one is a bus topology. They call it a bus. It's kind of like you're on a bus. You're going down the main backbone. This is the fastest cable that they have in the company or on the network. And the bus stops at this stop. Says, "Hey, you got any data for me?" Nope. And then the bus drives down here. "Do you have any data for me?" Nope. "Do you have any data?" "Yeah, I got a package. I need you to deliver to node number 6. "Okay. Do you have a package?" "Nope." "Do you have a package?" "Nope, but I got a package for you," and delivers it. So that's how it kind of works. It's like a bus going down the road, delivering it to different bus stops. That's how I think of it. It's not very efficient. It's kind of an outdated technology. It's not used much anymore because it's easy to extend and reliable. I guess it is. So there's some advantages to this. It depends on what type of work you have to do. I don't see bus networks really around anymore. It's more of a historical thing. So anyway, hierarchical topology, like the name, this computer here is the top of the pyramid, and then it can be sent off to the subordinates, and then that one can then send to the subordinates. If you want to go back to the top, you'd have to go through one of the subordinates to the top. So again, there is some it's somewhat problematic when transmitting data because there's a lot of wasted hops. They call these a hop. They go from this computer to this computer to get back. It'd be nice to go directly to that computer. Makes sense. Be a lot faster to do that. All right, so that's the hierarchical or the hierarchy topology. And there's some terms there. I'll let you guys go through this again. And I don't want to go through all the advantages. I'll let you read those. Mesh topology, like I said, this is probably the most common. This is really what the internet's based on. Looks like a spider web almost because, this think of it in a bigger scale. This could be Rogers. This could be Telus. This could be Bell. This could be whoever. All the different internet service providers and their services are connected. And from there, they've got other meshes that are connected or to their customers. So mesh technology is really good. What's nice about mesh is that if this computer goes down and I want to get to this computer, I can go directly to that computer, or I can even go to this computer and back to this computer. So that's why they call them a router. A router routes data. And the reason the internet is so powerful and reliable is that there's more than one route. It's like a bunch of highways. If I want to go to California, I've got multiple choices of roads to take. It's like a mesh highway system. So similar to the internet, I can reroute my data. So if a system goes down, like let's say there was a major fault in one of the services, then the data would take an alternative route to get there. And it might slow it down slightly, but it'll get there. Now there's a tool that you guys can use to actually see this. And I wanted to show this to you because it's kind of interesting. So let me put it on pause for a moment here and I'll show you the tool. All right. So this is a YouTube video that someone produced. I thought I'd show it to you because it's kind of shows exactly what I want to talk about. You can open up a command prompt window and type in a variety of these different commands. And what they're doing here is they're showing how you sitting at your computer connected to the internet, wanting to find some server on the internet and where it lives. And what you can use is and how fast it'll take to get back and forth through the internet. That internet could be a mesh network. So you could type in ping and then type in like HSBC or type in the IP address if you have it, it'll go through and it'll actually send out a little tone like a ping, and it's like the old submarine would ping, and they could find out how fast and how far away it was, and it tells you how many of the time to live and how many milliseconds it took to get there, which is really helpful if you want to increase the performance of your computer and your customers. So another thing you can do with this is you can not just ping, but you can also he uses another one here called trace the route. And what tracing the route will do, let me just find it here in the video, is it goes through, he's going to trace route now. So here you are on a network. So this is you got your house network router, and then your router is connected to the internet service provider. Your internet service provider then finds another router and then routes it all the way to the server that it's trying to send the data and the data communication. So we can use a term called trace the route, or RT, and then type in the address of that. And what that will do is it'll show you all of the hops from your computer. It hops to this router, hops to this router, hop, hop, hop. And right here it's coming up and it's telling you all the different computers that it took to get to that server, which is kind of neat. If you do this at Douglas College, they won't let you do this because this is considered a hacking tool, because you're basically identifying routers out on the network that you can actually then go in and try to look at or hack at. So they don't do that from the college. So anyway, but I want to show you that because it explains how a mesh network kind of works. Now, if you run that again, you might have different hops, because this router may be too busy and it might find another router over here and then redirect it through a mesh network. So that is probably the most useful type. Now this is another example. He's doing another trace route to a server, and they're blocking out the requests, or they've timed out, meaning that the servers they're not showing you. So if you can't get to a server, it says it's down, you can always use this trace route and then type in the IP address to see if it's down or not, or see if you can look for a different route to get there. And there's tools to do that. It's beyond the scope of this class, that's for sure. But there's a lot of videos out there that will show you how to do that. But my point there was to show you that a computer will hop from computer to computer before it finds its destination, and it could be different every single time that you do it. The other thing I wanted to make clear is that if I'm sitting here in Vancouver and I've got a server that's located in Toronto, I may not go directly to Toronto. I may dip down to Seattle. I may dip over to California. I may dip up to over to New York. I might then go to Toronto. If that's the case, the data has crossed the border. If it crosses the border, the National Security Agent in the United States, the NSA, will capture that data and they warehouse it, which is, it's just a fact of life with the internet. The Americans collect everything that travels through American servers, as do other countries. It's all, countries are very concerned about their data and what's being transmitted. Data is just so important, and the communication of that data is how people capture it and how they capture that information. All right, major network concepts. So in review of what we've been talking about, you should have an understanding that there are different protocols and be able to identify protocols, especially HTTP, HTTPS, TCP/IP, that Transportation Component Protocol, Internet Protocol. Those are two different protocols, work together to route data. What is routing? What's the concept of routing? What are routers or switches or hubs? What is the client-server model? Well, client-server model is you as the client connecting to a server and creating a session using a protocol, using IP, using routing and routers. So it all kind of works together to make the data happen. All right, now I think this one right here is when they're talking about protocols, and I'm going to get a little deeper into HTTP because we use it so often, and there's a great video right here I've attached you guys might want to have a look at, explaining what those protocols are in a little more detail, especially because we're in such a high security state right now with all the hacking going on. You should have a better understanding of what SSL is. So HTTP, of course, is for surfing the web. FTP is for file transfer. This is for sending out mail, sending mail, but not receiving mail. This is for sending and receiving mail. And again, this is another video on secured web surfing. So if you want to be secure, I'd highly recommend you have a look at that video right there. Just a little more on that TCP/IP protocol. It is the industry standard. You guys probably hear this all the time for communicating other protocols. So that's a protocol that's, it works at the router network for communicate to transmission of the data. We use the HTTP to send the hypertext. So that's another protocol. These protocols, they stack on top of each other. But this is pretty much the industry standard right now. This is what we use to really run the internet. So that's the transmission control protocol. Operates at the OSI at the makes sense, the transport layer, hence the name, transmission or transport layer. It helps to establish the links between the client and the server. It helps you connect you with your server. That's what the protocol does, and that's what the key to that is. Getting any deeper than that, I think in this course isn't really warranted. We have courses dedicated to this to get into this more specifically and understand it at that packet level. You will get a bit more understanding of this with the LinkedIn learning course that you have to do this week. So I would definitely encourage you guys to watch that as well. The IP, or the Internet Protocol, is that IP address. Operates at the OSI at the network level, because your network card has to have an address, and it has to be given by the Internet Service Provider, and it uses the Internet Protocol to get that Internet IP address. They call it the IP address. You guys have probably heard of that. Routing. Now, routing is the term routing just means to take data that's being communicated and route it to different devices, whether that's a hub, a switch, or a router. And we do that, and the data is bundled into what they refer to as a packet. And you guys can click on this Khan Academy. It has a great explanation of how a packet works. But basically, a packet is a collection of just zeros and ones that are sent from your computer. Again, the LinkedIn Learning goes into this in a little more detail, which is, he does a really good job at this. It includes what they call a message data, so that little packet of information, it's like a letter. On the letter, it has an envelope. It has, which contains the message. A letter has an address of where it's going to go to, and it has a return address of where it came from. So you could almost think of a message or a packet as a letter of data, and that letter has to be delivered. So that's the job of the router, is like the mailman or the mail person who has to deliver that letter. It has to deliver the packet or the package, which is just a group of zeros and ones. So again, routing is that process of deciding where that pathway of the data will go, and the routing can occur in different pathways. You can take different roads to get the same destination. If a road is blocked or there's a lot of traffic lights and it's slow, you might take a different route to get there. So the routing happens at the router level, and the router keeps track of all of its tables of where other routers are, and they're all constantly pinging these other to see how fast they are to give you the best performance. The company that runs those is called Cisco. So like Cisco routers is one of the larger ones, or D-Link, you might have heard of them. There's lots of them out there now. So routing tables, this is what I was saying, generates automatically by the software. You don't really do this, but your router is constantly looking at your internet service provider and other routers that it's connected to see who's got the fastest connection. And then when you make a request to send out and you want to create a session, it will find the best route to follow. It looks at the table and says, that table, it was like that video I showed you, that milliseconds. It'll show you which is the fastest router to connect to. And it makes the decision on your behalf based on which one is the lowest time, which would be the fastest. Ping command, I think I mentioned this. Ping is just allowing you to find out how fast it takes to get to a particular server. So if you typed in ping Douglas College, it would come back and say it's 23 milliseconds or whatever it happened to be. And you might think, well, what do you need that for? Well, it could be because the internet is getting slow. Like we deal with a lot of lag time. People say, oh, my internet's really slow right now. Well, we can use the ping command to determine where and how slow it is. And we can't really control the data because the routing tables kind of control that. But if the routing table realizes that there's a slow network, it will take a different route. How can we see the route? We can use the Traceroute command. And now they've got commands out there like this geo location, which actually shows you the map of the world, and it'll show you where the routers actually ping geographically, which is really cool. You can actually see your data on a map flying around the world. Let's see if I can find one of those. All right, I found it's called traceroute.com. You guys should try this out. It's really fun. What you can do is you can actually type in where you are. So it says here I'm in Vancouver, and I want to connect to the Douglas College server. And this is really interesting because look at the route it took. It went from Vancouver, it dropped to Seattle, it went over to Calgary and back to Vancouver. Now you might think, well, that sounds crazy. Why wouldn't it go from Vancouver to Vancouver? Well, it's probably because the route right now in Vancouver is blocked or slow or whatever. If I run this again, it could change the route. So I'm going to go back in, change Vancouver, Douglas College, and say trace the route again. And what it's doing is it's pinging all the different servers, and then it overlays it on a map of the planet, and it shows you where that goes. So I'll just it takes a little bit of time here, so I'll just pause it. All right, I ran it again, and I got the same thing. If you look here, there's a yellow and a blue. And that means that where I'm physically located is the blue, and my server is physically located in yellow. But you got to ask yourself, like, wow, look at the pathway it took in this mesh network. It dropped down to Seattle, over to Calgary, and back to Vancouver. Now you think, okay, well, it does it pretty quickly. Like, it also probably measures the time and how fast it took to get to Douglas. But here's the thing. I've made a request. Every time I go to the Douglas College webpage, the Americans, they know that I did that and what I'm doing because the data is sent through Seattle. Seattle's capturing all that data. No one's watching me, but that's being logged on a server in the National Security Agency of the NSA of the United States. You guys might remember that Edward Snowden blew the whistle about how our data during the data communications is being captured. So why I'm telling you this is that just keep in mind that everything you do online, there is a log of it somewhere. So I think right now there's been a case right now where Hillary Clinton had these emails apparently, and she had deleted her server, but because the data had been sent to other countries, the NSA had captured that. So it sounds like they do have the data, and they're actually going back and they're looking at that. So, I mean, that's a pretty extreme case. And, you know, we don't really have to worry about that as students, but it's good to understand that. Now, if you're working in a company and you're managing a managing information system and there's critical sensitive data, you should be aware of that. Are you working for a company like SAP and the data is very private and should be secure? And if it is, well, you don't want it dipping down into the US so that they have it or somewhere else they could get it. You have to know the route that the data is traveling for super high sensitive, top security data. And that's why Hillary Clinton was under so much scrutiny, because her data had been compromised. She tried deleting it, but as you know, they've got a lot of her email addresses and emails now, and they're actually releasing these. So it's really turned out to be quite a story. All right, moving on to the next one here. That was the Traceroute command. That was a big one. The routers, you guys probably recognize routers, and you probably there's a variety of these different routers. These are the antennas for Wi-Fi. You can also plug them in directly. They help control the... Now, if you want, you guys can actually go into your router at home, and you can do that by going into a browser and typing in your Wi-Fi IP address, which is usually 192.168.1.1, and that is my particular one. Now you might have a slightly different one, and that connects me. Look at this. I'm actually connected to my router, and I can open it up and I can type in my router password, and I can make settings and security and whatnot on that. I can log in as a guest or create guest accounts. This is my Linksys router, and I think that is by Cisco. I forgot now. It tells you how old it is. You can update your firmware on that kind of stuff. So when it comes to your router, you guys do have access to your router for setting up things like your password. You can also create guest accounts and modify this and actually track. And what I do with my router is I actually track to see who has tried to access my router. I live in a condominium, so my router is available to a lot of people around me. And then I go into my router and I see if there's a MAC address of other computers that have tried to access my router, and if they're trying to hack it. So I can do this with my neighbor's routers, and they can do that with my router. So I got to lock it down and be pretty secure with it. So I think even at a home level, as a user level, especially now that we're working at home, we have to be more aware of this, because we're not at school with security people that are monitoring and managing our data communications. We're doing this ourselves. So there's a risk here, a risk potential. If you guys are transmitting information over your router, other people potentially could have access to that. Now, is your data, that valuable? Probably not, but it's still a risk. All right, moving on. The static routers. Now, static is is usually fixed, and they have a fixed type of address. Now, you can get a fixed IP address that's connected to your router, and you always have that. Now, that would be useful if you've got you're hosting your own server at home, like what Hillary Clinton did at her home. She had her own server. She had her own static router IP address, and then created email server, a POP server, or an IMAP server. And for most people, we don't need this. We can have a dynamic router, which we have always changing IP addresses. Now, we can find our personal router IP address. Now, this is we can, by pinging or trace routing out of our computer, it will show us what our address is. I don't want to get into that because it's a little too technical, I think, for this class. And you will do some of this when you're in the LinkedIn Learning. So the dynamic router, again, like I said, the IP address changes constantly. And there's a difference between a public IP address and a private IP address. And again, that's way beyond the scope of the class, but static means you've always got the same IP address. It's like the same address on your house. I mean, it would be very problematic if your house address constantly changed. It was very, dynamic. You lived at one address and the next day you lived at a different address. But because these routers keep track of their tables, they can keep track of where you are on the internet. Now, the client-server model. This question gets asked all the time. What is it? And the client-server model is basically a computer connected through some form of network topology to some type of server. And when you have a session, that means you're working back and forth. That means that you have a client-server session, which is the client-server model. And this occurs in every device that you guys have, whether it's your laptop, your phone, or a desktop. You're always having to connect to a session. If I wanted to access my bank, I would type in HSBC here, go through the internet, and connect to the HTTP server for my bank, and I would create a client-server relationship. So you are requesting as the client, and the server is serving you the data and the information. Now, whatever managing information system you guys are working on, you're going to have a client-server relationship. So it really doesn't matter. Let's say you're using a program called Salesforce and you're in the marketing department, and you guys chose the Salesforce as a tool that you guys want to do for your presentation. Well, that is the Salesforce is connected to the Salesforce server, and you have to create that session, and you become basically asking questions of the server, and the server is providing you information. And that's basically how the client server works. Now, most client programs that you start off with is the browser. So the browser is the client, and the browser connects to some HTTPS server or an FTP server or a POP server, an email server, or what have you. There's all sorts of servers. There's literally dozens and dozens of different types of servers that serve different specific themes. All right. So the server is that remote computer on the network that provides information or services in response to the client's request. Very straightforward. When you make a request, like you want to know your emails, you get onto Outlook, which is the client, and the Outlook connects to a mail server that all your emails are on, and it sends you all your emails. Very straightforward. The advantage for a client server is it's scalable, meaning I could just keep adding more and more of these clients and I still use the same server. Fantastic for economics. And that's one of the key reasons, another key reason why companies follow this model all the time is because it's cost efficient and it's effective. Wireless security. Wireless security, there's a few things that you should be aware of. I think when you guys are setting up your router, you'll have different options for wireless security. Most people now use this wireless protection access 2 for all your wireless connections using this 802.11 standard. That's your Wi-Fi standard. It's a frequency, a radio frequency that your Wi-Fi uses at different bandwidths. So you need to set up your, and this is, I think, a 256-bit encryption between your computer and your Wi-Fi. But when you guys are working on let's say you're at Starbucks, they're using probably just a wired equivalent privacy, which is a very low hackable, easy to crack protocol. So I wouldn't use this because somebody around you could access your router possibly. You'll definitely want to use the highest level, which is your WPA2 now. All right, well, that brings us to the end, and I was pushing this one to get to the end, and this is pretty much a summary, which I'll let you guys read through. And I would encourage you guys, if you made it to the end of this video, congratulations. I know sometimes these can be a little bit dry, but definitely do the LinkedIn Learning and keep up with your classes with the videos. It helps correlate the class with the knowledge. And don't forget, you got a quiz on Friday, and I think that's it. All right, so I'll see you guys in the next chapter.